Hello, and welcome to your first lecture on lists and tuples. Yes, it said tuples. So we went over this a little bit when we talked about types in some of the very first lectures, but let's talk a little bit more in depth about lists. Lists are one of the objects that are a collection, and we define them using square brackets. So we'd say square brackets, item, comma, item, comma, item. So square brackets to begin a list and commas between each object in the list. And remember, lists can actually have multiple types of objects inside of it. So unlike things like arrays, if you've programmed in another language, lists can have a float, an int, a string, another list. It can have basically any object inside of it. Now, because lists are collections, just like strings, we can iterate through them. For instance, we could say for item in list to loop through all of the items in a list. Let's go to Python to see some of these and test them out. All right, so we have a list here, L, and it starts and ends with square brackets, and in between each object in the list is a comma. In this case, it's a list of strings, Tan, Anthony, Karamo, Jonathan, and Bobby. Because lists are collections, we can iterate through them using for loops. So I'm going to say for, and then the name of a just placeholder variable. I'm going to call this one fab, but you could call it whatever you would like. And then in, and the name of the collection that I would like to loop through. In this case, I'm going to say print I love, and then the name that it's currently on. So when we go ahead and run this code, it should first have fab equal to tan, so it'll print out I love tan. Then on the next iteration, fab will be equal to the second item, Anthony, and it'll print out I love Anthony, and so on and so forth till it prints out all of the names in this list. Let's go ahead and try it. Awesome, so you can see it printed out I love Tan, I love Anthony, I love Karamo, I love Jonathan, I love Bobby. Let's do another example. We're going to have x equal to 1, 2, 3, 4, 5, 6. And I'm going to say for I, we can call this whatever we want, in x, print I squared. So on the first iteration, I is going to be equal to the first item in the list 1. On the second iteration, 2, 3, 4, 5, 6, all the way through each item in this collection. So let's comment this out, and we're going to say, okay, this is going to print the squares of the numbers 1 through 6. So we're going to go ahead and run that, and we can see, yep, 1, 4, 9, 16, 25, and 36. Let's do another example. So we have a list that contains strings representing each day of the week. So we're going to say for days in, or say for day in days, if day equals Tuesday, print it's taco time, because it's Taco Tuesday. So when we run this, it's going to iterate through each day in the list, and it's going to check if the day is equal to Tuesday. If it is, it's going to print it's taco time, otherwise it won't print anything at all. So when we go ahead and run this, you can see that it printed it's taco time once, and that's because there's only one Tuesday in our list. So just like strings, we can index lists using the indices, and we can either slice or just grab something at one index. For instance, let's say print days, that's our list days, bracket 0. That's going to print the 0th, or the item at the index 0, from the list days. In this case, that should be Monday. Let's check and see if that's correct. I'm going to run that, and exactly, it prints out Monday for us. We can also slice our list, so we could say from the list of the guys from Queer Eye, grab me the items at index 2 to 4. And remember, that's up to 4, not including. So let's go ahead and print that out and run. So in this case, it printed out Karamo and Jonathan, and if we scroll back up to our list, that makes sense because Karamo's at index 2, 0, 1, 2, and it printed up to but not including index 4, so that would just be index 3. Like with strings, these arguments have defaults. If we don't put a default for the first argument, it says that we want to start at the beginning of the list. If we don't put an argument for the second one, it says that we want to go all the way to the end of the list. And finally, we can also use that negative argument if we want to get something backwards. So in this case, if we wanted to get that list of the Queer Eye guys backward, we could use a -1, which you can see is exactly what prints out down here. Now, unlike strings, lists are mutable, which means we can change individual objects inside the list without creating a whole new list. For instance, let's say that from our list of the Queer Eyes, Tan got replaced with Tim. we can actually change that by saying the name of the list, square brackets, the index that we would like to change. Tan is at index 0, so we'd put 0. And then we would say equals Tim. This is basically saying take the object at index 0 and change it from whatever it was to be Tim. Now when we print out the list, let's print L, you can see that Tan has been replaced with Tim. This is unlike with strings where we couldn't do that at all. Once we created a string, that was it. The only way to change it was to create an entirely new string. That's because strings are immutable. However, lists are mutable, which means we can change individual objects inside of them without creating a new list. All right, let's talk a little bit more about some complicated lists. In this case, we have a variable called spreadsheet, which contains a list whose objects are also lists. So it's basically lists within lists. We can call these nested lists. Now, we worked with simple indexing before, but let's talk about how it works when we have collections inside of collections. Say I wanted to grab the string Bill from the variable spreadsheet. Well, first I would say spreadsheet, and then I would say, okay, well, Bill is in 0, 1. He's in the list at index 1. However, Bill is the first item within that sublist. To grab just the string Bill, I would have to say 0 at the end here. So basically this portion grabs this list, but the entire list. And this 0 says, well, from that list we just grabbed, grab me the item at the index 0. So when we print this out, this should be just the string Bill. So we'll say print spreadsheet 1, 0. And let's go ahead and comment out all of this. And when we run this, we can see that we indeed get just the string Bill. If we didn't have this 0 here, I'm going to get rid of it, then we would actually print out this entire list, because this entire list is what is at the index 1 of the list spreadsheet. And when I go ahead and run that, you can see that's exactly what happens. All right, let's try another one. I want to grab 3.7 from the variable spreadsheet. Well, it's in the 0, 1, 2, 3. It's at index 3. So we're going to put 3. And then within this list, it's at index 0, 1, 2. So we're going to put a 2. So when I print this out, this should print out just 3.7. And that's exactly what happens. Let's take a break from lists and talk about tuples. So we just learned that lists, unlike the other collection we've talked about so far, strings, are mutable, meaning we can change individual objects inside of them. However, sometimes we want something that looks like a list but isn't mutable. This can often be the case, 1, if we want to save memory because we know that the list can never change, or 2, because we want to be very careful that a user could never, even if there's a bug in our code, change the list. Well, it turns out that immutable lists are something called tuples. Tuples look a lot like lists, but we define them with parentheses instead of with square brackets. So for instance, if we wanted to have a tuple here, we would say parentheses, and then just like with lists, put commas between the individual objects. Like lists, tuples can have different types within it, but the only difference is that tuples are immutable. So once you create them, you cannot change them. Just like with strings, if you wanted to change it, you'd actually have to create an entirely new tuple and reassign it to the variable you were using. Let's go to Atom to see how this works. Okay, let's create a tuple. We'll say my tup equals 1, 2, 3, 4, 5. And we can still grab or slice or index tuples the same way we do with lists. So we could say my tup bracket 0. And if we wanted to, we could print this out. Go ahead and do that, comment out this. And when we do that, you can see that we can still grab individual objects. So we grab the object at index 0 of this tuple, and it's 1. What's different, though, is that we cannot change this object. We can grab it and use it, but we cannot change it. For instance, in a list, we saw that we could say something like the name of the list, my tup bracket 0 equals, and we'll just say equal to 0. Now in a list, this would change the item at index 0 to be 0. So it would change this 1 to a 0. Let's see what happens when we try and do that with a tuple. Ooh, okay, so we got a type error. And that's because tuples, like strings, are not mutable. Once we create them, we cannot change them the same way we can with a list. So tuples are really useful if you never want to be able to change your object. If you think that there's a possibility that you would like to change your object without having to create an entire another one, lists are going to be the way to go. And since we're back to talking about lists, I just want to really quickly show you about nested for loops. So in this variable that we created, spreadsheets, we have lists within lists. And if we wanted to loop through these lists, we actually can. We would do that with a nested for loop. So we could say for row in spreadsheet. So this is going to say for each object in the list spreadsheet. Well, the first object is this entire list. The second object is this list. Third here, fourth here. But we can say, okay, well, each of those sub items is a list itself, so I could loop through those. So I could say for cell in row. So I'm saying for each of the sub objects that I'm looping through, actually loop through that object as well. And I would say, let's say print cell. So this is going to first loop through each of the bigger lists, and then within each of those lists, it's going to loop through them and print out each individual object within that sublist. Let's go ahead and see what happens when we actually run this. All right, so you can see that it went through the bigger list, and it first looped through this list and then printed out each individual item in that list, name, age, GPA. Then it looped through this list and looped through each item to print it out, and then it did it for the last remaining two sublists as well. Remember that once we grab a list from another object, even if it was part of a bigger collection before, we can still treat that item as the collection that it is. So if we grab a list from a bigger list, we can still loop through that smaller list that we grabbed. All right, that is all that I have for you. I will see you next time.